Mrs. Banky here. The goal of today's lesson is to teach you about what is called the mole in chemistry. And as you can see up here on the learning objectives, we're going to define mole and talk about what that means in chemistry. We're going to learn how to calculate the molar mass of a substance and also how to calculate the percent composition of a substance. So that is the goal of today's lesson. To get the lesson started off, I had students naming writing formulas for compounds. And I reminded them that there are two types of compounds. The type of compounds that involve ions, which are ionic, and then the type of compounds that contain two nonmetals, which use prefixes in the naming. So I have the starred ones, the ionic ones are starred ones, and I told students that they had to make sure they wrote the ion charges to get the right formulas. So looking at this calcium fluoride, the formula, because of the crossover rule, becomes CaF2. The next one, when I see prefixes like that, a reminder that that di is attached to the carbon, so that means there's two carbons, C2, and hexahydride means that there are 6 hydrogens. Nitrogen dioxide, 1 nitrogen, 2 oxygens, NO2. And ammonium sulfate is an ionic compound. It's a little more complicated because of the 2 polyatomic ions that are there. Ammonium has NH4 with a +1 charge, and then sulfate is SO4 with a -2 charge. So when I use the crossover rule, I need 2 ammoniums and 1 sulfate. Copper 2 nitrate, the 2 comes down in front of this nitrate group to give us CuNO3, 2, and then dicarbon tetrahydride is C2H4. One of the things with the molecular compounds, those that contain prefixes and nonmetals, is that we don't simplify them into simpler compounds, because what we're saying here is that 1 molecule of dicarbon tetrahydride will have 2 carbons and it will have 4 hydrogens. So the next part of the lesson, I'm just going to introduce the definition of a mole as a counting number, and then I'm going to suggest you pause this and watch a couple of videos that I put on Neo, and then come back to this when you're done. So by definition, a mole is a counting unit used in chemistry and just like 1 dozen equals 12 or a pair equals 2, the mole is a counting unit. So 1 dozen equals 12, 1 pair equals 2, 1 mole is equal to, wait for it, it's a really big number, 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. This number is also called Avogadro's number. Not avocado, Avogadro's number. And the video that I'm going to have you watch will describe the role of Avogadro. So one thing that I am going to tell you is that we have a celebration coming up soon in which we are going to celebrate a very special holiday in the chemistry community called Mold Day. Now, it officially starts at 6:02 in the morning and ends at 6:02 at night on the 10th month of on the 23rd day of the 10th month. All right, so October 23rd is Mold Day. This is an international celebration for chemistry geeks like myself, worldwide. There are gatherings, it's a special occasion, there are festivities, and we're also going to celebrate in here Mold Day. And I'll talk more about those, what we can expect with that celebration later. So at this point, you should go on to Neil into the lesson that it should be at the top in our class. It talks about the mole and calculations using a mole, and I have 2 videos there for you to watch. So at this point, you should watch those 2 videos. Okay, I'm back. I hope you enjoyed the videos, and I hope that you look forward to celebrating Mold Day this year. It's a Friday. I'm not sure if I use this video in the future, if it's going to be on a Friday, but the year that I'm making this video, it is on a Friday. And it will be fantastic. I think we may have some competitions, and we'll call them the Molympics. And maybe we should have some guacamole. I wonder if anyone would be willing to bring some guacamole to our festive occasion to celebrate Mold Day. Now, in the second video, the TED Ed video, he talked about using, going to the market to get salami and how it's bought in pounds rather than slices. And we have a connection between mass and moles in chemistry that's very useful to us because we don't have any little machines that sit and counts atoms one by one. So we have an electronic balance that gives us the mass. Now, the unit that's useful to us is something called molar mass. And the molar mass of a substance is equal to, it's equivalent to the atomic mass, which can be found on the periodic table, in grams. So So again, it's the molar mass is equal to the atomic mass of a substance in grams. For example, as I look up on the periodic table, I know that you can't see this right now, but I'm looking. I see that the atomic mass of copper is 63.55. So the atomic mass of copper equals 63.55. Again, that number's coming from the periodic table. So 1 mole, and mole is shortened. The unit for mole is shortened to MOL. I know that that's not shortening it very much, and I have it in cursive here, so I'm just going to get rid of it in cursive. So 1 mole of copper equals 63.55 grams. Since the mass of aluminum is 26.98, 1 mole of aluminum is 26.98 grams. Now the next thing to think about is compounds. What would the molar mass be of water? I am looking for my eraser here. I hope that this swivel is not making you dizzy. It's kind of an automated thing that's causing the camera to move. So it's making you dizzy any more than my hairstyle could be making you dizzy. I apologize. So I want to to talk about the molar mass of water. I hope you like my new hairstyle, by the way. I had a barrette in it, but it didn't really fit very well. This is the first time I've ever tried this color. So the question is, 1 mole of H2O, water, is how many grams? Now what we have to do here is we have to look at the compound formula and look at how many of each element there are. I have 2 waters, or 2 hydrogens, and hydrogen has a molar mass of 1.01 on the periodic table. Oxygen has a molar mass of 16.00. So what we have to do is we have to take the amount for each atom and then add them all up. So we have 2 hydrogens. 2 times 1.01 is 2.02 grams. We have 1 oxygen. 2 times 16.00 is, oh, I made a mistake. I'm sorry. There's only 1 oxygen, so 1 times 16.00 is 16.00. And the total is 18.02 grams. So 1 mole of water is 18.02 grams. Now since a gram of water is equivalent to a milliliter, this is very small amount of water. If you remember in the video, about 3.5 teaspoons, that's not a lot of water. And to imagine that there are 6.02 times 10 to the 23rd atoms, or molecules of water in a sample of water that is less than 3 teaspoons worth of water. That's crazy. So my next task for students at this point of the lesson was to take all of the formulas that they just calculated and add up the molar masses. So I'm going to pause the video for a second and I'm going to put those molar mass values in. I just have to move this over a little bit. I'm just going to go through one more example. Calcium, when I look on the periodic table, has a mass of 40.08. Fluorine has a mass of 19, and there are 2 of them. So when I take 40.08 plus 19 plus 19, I get 78.08 grams for the molar mass of calcium fluoride. Now one of the important things to be able to do is identify which elements are there and how much. So C2, 2 carbons, 6 hydrogens, 1 nitrogen, 2 oxygens. Sometimes you get a beast like this where you have parentheses and subscripts outside. This 2 here belongs to everything within the parenthesis. So, and it multiplies through. So without it, I have 1 nitrogen and 4 hydrogens. When the 2 is there, it multiplies through. Now I have 2 nitrogens and 8 hydrogens. A common mistake is for students to say that there are 6 hydrogens, but remember it has to multiply through. 1 sulfur, 4 oxygens. Here we have 1 copper, 2 nitrogens, because of that little subscript 2, and 6 oxygens, and then 2 carbons and 4 hydrogens. So I'm going to pause this for a second. In a moment, I will bring it back. Okay, I'm back. I keep looking over there because I don't know why I keep looking over there. But the camera's right there. So in order for me to speak at you, I keep looking over there. I just keep looking at myself. I don't really understand it, but I have to remember that the camera's right there. So I'm sorry if it seems that I'm looking at someone else, but it just might be the case. Till I get used to this, I guess. So a reminder that I have all of the molar mass values here. A reminder that to get molar mass, we have to take the mass of each element and add them together to get a total. In the next part of this activity, I'm going to be talking about nitrogen dioxide in an example. And nitrogen dioxide, NO2, has a molar mass of 46.01 grams. So the next thing that we're going to learn in this lesson is called percent composition. Sorry, I had to fix that. Percent composition. Sometimes in science there are unknown substances, and you can get an unknown substance and run it through a machine. The results that may come back out is the elements that are present and the percent that the elements are present, which can sometimes allow us to identify unknown substances. Also, knowing about the percent composition of substances, it can work the other way around, where if we know the percent composition of substances, we can get back to what the possible substance is. So, all things aside, percent composition is the percent by mass of each element in a compound. To get percent composition, we have to use molar masses of substances. For this type of calculation. There's another way you can get percent composition, and that's through analyzing lab data or data collected in the lab, which is something that we will be doing in here as well. But one way we can get percent composition is using molar masses. So here's the question. What is the percent nitrogen and oxygen in, 1 second. I need you guys to not talk to each other, okay? All right, I'm back. I have some friends in here that are making kind of some noise. So here's the question. What is the percent nitrogen and the percent oxygen in a sample of NO2, nitrogen dioxide? To get the percent composition, there's a formula, and it's very simple. We have to take the mass coming from the substance divided by the molar mass times 100. So at first glance, when you look at NO2, I asked students what percent nitrogen is there, and a common response was, well, it must be 33% because there's one nitrogen atom and two oxygens. So there would be 33% nitrogen and 66% oxygen. But what we're going to discover here is that each element has a certain mass, and it's being applied to that total in different ways. So the amount of mass coming from the nitrogen in NO2 so the percent nitrogen is 14.01 grams. And if I divide that by the molar mass, 46.01 grams, times 100, I get 30.4% nitrogen. I'm just going to write this out and then I'll explain it. So the percent oxygen is the mass coming from the oxygen, and NO2, since we have two oxygens and each oxygen is 1632 divided by the molar mass times 100 gives 69.6%. And one thing that you will notice is that these numbers will add up to 100. Sometimes when you're checking your work and you're trying to add up those numbers to 100, rounding errors can cause it to maybe be slightly over 100 or slightly under 100, and that's normal. It's nothing to worry about. So that's all I have today. I hope if you're absent because you're not feeling well that you're feeling better, or if you're just using this for some reinforcement, I hope that it helped. See ya.